What if we could harness the same energy that powers the sun and the stars? That's the question at the heart of the quest for nuclear fusion, the process that fuels the celestial bodies that illuminate our night sky. In the vast expanse of the cosmos, stars like our sun are the ultimate power plants. They generate colossal amounts of energy through nuclear fusion, a process where hydrogen atoms are squeezed together under tremendous pressure and temperature, resulting in helium and an enormous release of energy. This energy radiates outward, lighting up the star and warming its surrounding planets. To put it into perspective, every second, our sun produces enough energy to power human civilization for about 500,000 years. And it does this by fusing about 600 million tons of hydrogen into helium every second. Yet, here on Earth, our primary method of nuclear power generation isn't fusion, it's fission. In nuclear fission, the nucleus of an atom is split into two smaller fragments, releasing a significant amount of energy. Yet, this process has its drawbacks. It produces radioactive waste that remains hazardous for thousands of years, and there's always the risk of a nuclear meltdown. But what if we could mimic the stars? What if we could bring the power of nuclear fusion down to Earth? The potential benefits are staggering. Fusion produces no long-lived radioactive waste and is fueled by plentiful elements like hydrogen and helium. Plus, in theory, a fusion power plant could never melt down. While nuclear fission is like breaking a stick, fusion is like squeezing two sticks together so tightly they stick. It's a process that requires incredibly high temperatures and pressures, conditions that are challenging to achieve and maintain on Earth. But if we can figure it out, we could unlock a virtually limitless supply of clean, safe energy, an energy source that could power our world for millions of years. Imagine if we could replicate that process here on Earth, creating a virtually limitless supply of clean energy. It's a tantalizing prospect, one that could transform the way we power our world. And that's what we're going to explore in this video. Ever wondered about the specifics of this cosmic dance we call fusion? Let's break it down. In the heart of a star, the extreme pressure and heat cause hydrogen atoms to move at incredibly high speeds. As they zip around, they collide with each other with so much force that they overcome their natural repulsion, a phenomenon known as the Coulomb barrier. This is like trying to slam two repelling magnets together with enough force that they stick. Now, imagine this happening not with just two atoms, but with billions upon billions all at once. The result? A spectacular release of energy. This is nuclear fusion, the process that lights up the stars and potentially our future. Picture this: two hydrogen atoms hurtling towards each other at breakneck speeds. They collide, their cores merging to form a single heavier atom. The excess mass is expelled in the form of energy. That's fusion in a nutshell. But reproducing these stellar conditions on Earth is no easy feat. It requires us to heat our fusion fuel, a form of hydrogen, to temperatures over 100 million degrees Celsius. That's hotter than the core of the sun, and we need to maintain this heat long enough for fusion to occur. It's like holding a small piece of a star in a bottle without letting it touch the sides. The challenges are many, but if we succeed, the rewards will be monumental. So, how close are we to achieving this? Let's delve deeper into the science behind it all. Before we delve deeper into the science and challenges, let's take a step back and understand how we reached this point in fusion research. The concept of nuclear fusion, believe it or not, has been around for nearly a century. The idea was initially proposed in the 1920s by English physicist Francis William Aston, who won the Nobel Prize for his mass energy equivalence principle, the very foundation of fusion energy. Picture this: a young scientist, Aston, standing before a crowd, explaining that the fusion of hydrogen atoms could lead to a nearly limitless source of energy. Fast forward to the 1950s, when the first attempts to control nuclear fusion were made under the project name Project Sherwood. These were the first steps towards taming the power of the stars. Imagine the excitement, the anticipation, as scientists around the world raced to unlock the secrets of the stars. However, the road to fusion has been anything but smooth. Each breakthrough was hard-fought, with many dead ends and setbacks along the way. In the 1990s, the joint European Torus, JET, achieved significant fusion power output, a major milestone in our journey. Imagine the buzz in the room as the JET team watched the first significant fusion power output. And now, we're on the brink of another breakthrough, with projects like ITER and NAF pushing the boundaries of what's possible. As we stand on the shoulders of the giants who came before us, we continue to push forward, ever closer to harnessing the power of the stars. But as we've seen, the path to fusion is not easy. It's a journey of 1,000 steps, each one bringing us closer to a brighter, cleaner, fusion-powered future. Having journeyed through the history, let's land in the present. Welcome to the cutting edge of fusion research. The research of nuclear fusion has never been as exciting as it is today. Scientists around the globe are working tirelessly to turn this dream into reality. Let's take a look at some of the latest developments. Imagine stepping into a world where the power of the stars is within our grasp. First, we have the ITR project, an international collaboration aiming to build the world's largest tokamak, a device designed to contain the superheated plasma where fusion occurs. Picture a machine so complex and advanced it could hold the key to limitless energy. ITER's goal is to produce 10 times more energy than it consumes, a major step towards making fusion energy commercially viable. Imagine the buzz as the ITER team edges closer to this ambitious goal. Then we have the National Ignition Facility in the US, which uses powerful lasers to heat and compress a small pellet of fusion fuel. Their goal? To reach the point of ignition, where the fusion reaction becomes self-sustaining. Picture a tiny pellet, smaller than a pea, containing the potential to power a city. In the UK, we have the START, Small Tight Aspect Ratio Tokamak experiment, which achieved a world record for plasma pressure in a magnetic confinement device, a key parameter for achieving fusion. Imagine the thrill as the START team smashed the world record, bringing us one step closer to fusion energy. Each of these projects represents a piece of the fusion puzzle. As we continue to push the boundaries of what's possible, we get closer to harnessing the power of the stars. As we stand on the brink of a new era, we can almost feel the heat of the fusion-powered future. But as we've seen, the path to fusion is not easy. It's a journey of 1,000 steps, each one bringing us closer to a brighter, cleaner, fusion-powered future. Having explored the cutting-edge research in fusion, let's step into the future and imagine the broad applications of fusion energy, beyond just power generation. Fusion power holds the promise of providing safe, clean, and virtually limitless energy, but its potential applications stretch far beyond just powering our homes and cities. Imagine a world where fusion energy powers not just our homes, but also our industries, our vehicles, and even our space exploration missions. First, let's look at desalination. Fusion energy could provide the vast amounts of power needed to make seawater desalination viable on a global scale, providing fresh water to millions, if not billions of people. Picture a world where freshwater scarcity is a thing of the past, thanks to fusion-powered desalination plants. Next, let's consider transportation. Electric vehicles are the future, but what if we could power them with fusion? Imagine cars, trucks, and even ships powered by compact fusion reactors. Imagine a world where the phrase "running on empty" is no longer relevant, thanks to fusion energy. And then, there's space exploration. The immense energy output of fusion reactions could be used to propel spacecraft at unprecedented speeds, cutting travel time to Mars from months to weeks, or even days. Picture a future where interplanetary travel is as common as international travel is today, all thanks to fusion energy. Finally, let's not forget about industry. Many industrial processes require vast amounts of energy, and fusion could provide a clean, sustainable solution. Imagine an industrial sector powered by fusion energy, drastically reducing its carbon footprint. As we can see, the potential applications of fusion energy are vast and varied. And while we are not there yet, the progress being made in fusion research brings us closer to this future every day. As we continue to unlock the secrets of fusion, the future looks brighter than ever. In the midst of all this talk about nuclear fusion, it's not uncommon for misconceptions to arise. Let's take a moment to debunk some myths and clarify the facts about this promising energy source. Myth 1. Nuclear fusion is the same as nuclear fission. Fact. While both processes release energy, they do so in different ways. Fission splits heavy atoms into lighter ones, while fusion does the exact opposite, combining light atoms into heavier ones. Fusion is the process that powers stars, and it's what we're striving to replicate here on Earth. Myth 2. Nuclear fusion is dangerous and can lead to catastrophic accidents like Chernobyl or Fukushima. Fact. Fusion reactions are inherently safe. Unlike fission, a fusion reaction will stop if conditions aren't perfect, and there's no risk of a runaway reaction or meltdown. Furthermore, fusion doesn't produce long-lived radioactive waste, making it a much cleaner process. Myth 3. The fuel for fusion is scarce. Fact. Quite the opposite. The primary fuels for fusion, deuterium and tritium, can be extracted from seawater and lithium respectively. This makes fusion fuel effectively limitless, as there's enough deuterium in seawater to power the Earth for millions of years. Myth 4. Fusion energy is just a pipe dream. Fact. While it's true that there are still challenges to overcome, significant progress is being made. Remember, it took over 100 years to fully harness electricity after its discovery. Fusion research is a complex field, but every day, we're moving closer to making fusion energy a reality. So, while the road to fusion energy may be long and winding, it's a journey worth taking. Remember, the stars in the sky show us what's possible. Fusion isn't just a dream, it's the future. The science behind nuclear fusion might seem complex at first, but it's actually quite simple when you break it down. Nuclear fusion is essentially the process that powers our sun and all the other stars in the universe. It involves two light atomic nuclei coming together to form a heavier nucleus. Yes, it's a bit like a cosmic dance where two atoms waltz so close together that they end up forming one. But this dance isn't easy to pull off. Imagine trying to push two powerful magnets together. Just as their similar poles repel each other, so do the positively charged nuclei. This is where the term nuclear strong force comes in. It's the powerful force that overcomes this repulsion and allows the nuclei to fuse. But to achieve that, we need extremely high temperatures and pressures, conditions akin to those found in the core of the sun. We're talking millions of degrees Celsius here, folks. Now, when these tiny particles do manage to come together, they form a heavier nucleus and release a tremendous amount of energy. This energy is what we're after. It's the same energy that lights up the stars and our very own sun. Here's the fun part. The fuel for fusion is found in abundance in seawater in the form of a type of hydrogen called deuterium. Plus, another potential fuel is helium-3, which is abundant on the moon. So, in theory, we have a nearly limitless supply of fuel for fusion energy. Now, you might be wondering, if the process is so simple, why isn't it powering our homes already? Well, the catch is in the conditions needed for fusion. Recreating conditions similar to the sun's core here on Earth is, as you can imagine, quite a challenge. It's like trying to bottle a star. So the big question is, why aren't we using this seemingly perfect energy source already? As promising as nuclear fusion sounds, there are considerable challenges we need to overcome. But what exactly are these hurdles standing in our way? First, let's talk about the tremendous conditions required for fusion to occur. To replicate the power of the stars here on Earth, we need to achieve incredibly high temperatures. We're talking millions of degrees Celsius. These extreme temperatures are necessary to overcome the natural repulsion between atomic nuclei, allowing them to collide and fuse together. But creating these conditions is no easy feat. It's like trying to hold a piece of the sun in a jar, without the jar melting. Current technologies use magnetic fields to contain the hot plasma, but maintaining the stability of this plasma is a delicate balancing act. Secondly, there's the matter of pressure. The pressures at the core of the sun, where fusion takes place, are immense. Achieving these pressures on Earth is a Herculean task. Scientists are still grappling with how to create and maintain such extreme conditions in a controlled environment. Thirdly, we need to consider the energy balance. For fusion to be a viable source of power, the energy produced by the fusion reactions must exceed the energy put in to create the conditions for these reactions. Currently, we're still operating at a net energy loss, which obviously isn't ideal for a power source. Despite these challenges, research and development continues unabated. From the ITER project in France, aiming to create the world's largest tokamak, to smaller, more nimble startups exploring alternative approaches, the race is on to crack the fusion puzzle. As we grapple with these technical challenges, it's important to remember this isn't just about scientific curiosity. It's about finding a clean, sustainable, and virtually limitless source of power that could revolutionize our world. Despite the challenges, the potential rewards of nuclear fusion are too great to ignore. We may not have all the answers yet, but one thing's for sure. The journey towards fusion power is a journey worth taking. The race is on to unlock the power of nuclear fusion. But what could this mean for our future? Imagine a world where energy is abundant, clean, and safe. A world where power plants no longer belch out harmful pollutants, and where the glow of city lights is powered by the same process that lights up our sun. This is the potential future that nuclear fusion could bring. Nuclear fusion, if successful, could revolutionize the way we generate power. Today, most of our energy comes from fossil fuels, a finite resource that emits harmful greenhouse gases. Fusion energy, on the other hand, produces no greenhouse gases, and its fuel source, hydrogen, is virtually limitless. But the benefits of fusion energy extend beyond environmental sustainability. Fusion power plants would be inherently safe, with no risk of a meltdown or the production of long-lived radioactive waste. This stands in stark contrast to our current nuclear power plants, which rely on fission reactions and pose significant safety concerns. Moreover, fusion energy could provide a reliable, constant supply of power. Unlike renewable energy sources such as wind and solar, which are subject to the whims of Mother Nature, fusion energy could produce a steady stream of electricity, day and night, rain or shine. But perhaps the most exciting implication of fusion energy is its potential to power our dreams of space exploration. The same process that could light our cities could also fuel our spacecraft, enabling long-duration space missions and opening up new frontiers of exploration. Of course, all of this is speculative. The path to sustainable fusion energy is fraught with challenges and uncertainties, but scientists around the world are working tirelessly to crack the fusion puzzle, and with each passing day, we inch closer to that tantalizing future. With continued research and innovation, nuclear fusion could truly be the holy grail of power generation. Nuclear fusion? It's a big idea with even bigger potential. As we've delved into today's topic, we've discovered that fusion energy isn't just a sci-fi fantasy, but a tangible prospect that scientists are passionately pursuing. This powerful force, which lights up the stars and gives life to our universe, could potentially solve our energy needs here on Earth. The science behind nuclear fusion is incredibly fascinating. It's all about harnessing the energy produced when atomic nuclei come together to form heavier nuclei. This process releases energy in staggering amounts, and unlike its cousin nuclear fission, fusion promises a cleaner, less hazardous solution. But, as we've seen, the road to achieving sustainable nuclear fusion isn't without its hurdles. The conditions required for fusion are extreme. Replicating the heart of a star here on Earth is no small feat. The challenges are immense, from creating and maintaining the necessary high temperatures and pressures to the engineering feats needed to contain the reaction. Yet, despite these challenges, the future of fusion energy looks promising. Research efforts are ongoing and breakthroughs are being made. Experiments like ITER and facilities like the National Ignition Facility are leading the charge, inching us closer to a potential fusion-powered future. The rewards of nuclear fusion are too significant to ignore. A clean, virtually limitless source of power could revolutionize our energy landscape, drastically reducing our reliance on fossil fuels and mitigating the impacts of climate change. It's a tantalizing prospect, one that could redefine the way we power our world. So, will fusion energy become a reality? Only time will tell. But one thing is certain, the quest for fusion energy is a pursuit worth watching. And remember, if you enjoyed the video, don't forget to subscribe to Brainiacata for more thought-provoking content.